Our second speaker is Dr. Cheryl Glazebrook. Cheryl's an assistant professor in the Faculty of Kinesiology and Recreation Management at the University of Manitoba. Penny didn't give me any crib notes in terms of Cheryl's administrative work for NASPA or awards or things like that, but that's quite understandable as she's much younger than Howie and Mark. Much younger, in fact. But I will note that she has, in a very short time, generated close to $1 million in research funding at the University of Manitoba. And on a personal note, I had the distinct pleasure and honor to serve on Cheryl's PhD thesis committee, and it's a great honor to see her today and introduce her to you.
I'd like to start by thanking Howie and the rest of the committee. I'm very honored, but like Mark, started off very thankful and honored and then really enjoyed the process, Howie. So thank you for this opportunity. I am excited to add fortune teller to my list of other things that I do as an academic. The outline for my talk today, I decided to take a metaphor of a train, and we're going to start by exploring a little bit about why I use this idea of a train, and then explore the value and the interest in fundamental research and how I see that connecting to the applied realms that we've been talking about. I will look at a few new routes that I see us taking in motor control and learning, and then some ideas for where I see us and needing to move forward in laying down our next steps in the next decade. And finally, just a summary to pull things together and move forward. So I started with the idea of a train on the concept of integration, and much like Mark, I was interested in the idea that moving forward we'll really gain traction by integrating our different disciplines and working together for broader applications. The more I thought about it and talked with my students, I saw a lot of different parallels with the idea of a train. The train has stood the test of time, and I think that comes from the strong design that it had. It's been able to adapt over time and changing technology, and still today is something that we're continuing to invest and adapt, and it's integrated with newer technology. So we arrive at an airport and we hop on a train in order to get to the next place we need to go, and we work with our cars, but it's still being adapted in terms of high-speed trains and helps us get to different places. I think a train is also very apt for this talk because it represents a journey. So as a NASPA train that formed in 1967, we've been moving forward through those 50 years, and people have gone on and got off that train, but as a group we've been working towards a common goal of understanding motor control and learning and sport and exercise psychology. So we've adapted, and the methods and paradigms we've seen yesterday and today have changed over time, but that timeless design of understanding how it is that we move, and what I like to think about is the strategy that we use to be able to learn and control these different skilled movements has remained throughout that time. But another piece that one of my students highlighted is that trains are inherently social, and while the ways in which we interact with each other socially in between conferences have certainly changed, from writing letters and putting them in the mail to email, and now even just straightforward text messages, the elements and the importance of the social interaction of coming together, I think, will continue across the next decade. So in terms of fundamental research, I wanted to start with an example from GPS. So when I started grad school, we hosted SCAPS in Hamilton in 2004, and one of our tasks as graduate students was to walk around the area of the conference hotel and find where you could eat and find the pubs, although Dig had a pretty good list of those already. And we had to make our list and make sure we had directions and identify how much they cost and which ones really we as locals recommended. And now we can arrive and our tablets or our phones will tell us where we are and tell us exactly how to get there, and we can quickly find out where are the good places to eat and where we want to go. But the technology, and my point here is that the technology that we had or that was required to develop GPS was not first developed with GPS in mind. Nobody thought it would be really good if we could go to a conference and not have to have the grad students spend their time walking around and coming up with these maps. Instead, a group of physicists just wanted to figure out if they can make this atomic clock. And so they explored these ideas and were successful in doing that. But then somebody else took that technology and adapted and developed the GPS. And I'm quite certain that the original developers had no idea that someday then we would have Pokemon Go as a new means of getting out and making people active. So we needed different brains to come together and think through these different applications. So fundamental research, there are so many different applications that can come from that original work. And this is a quote from one of the developers of that original atomic clock. He says that, "In my view, basic science is the best thing that mankind pursues, not so much because it leads to new applications, but because it leads to new understanding. For me, there's no greater pleasure than the joy of discovery." And that joy of discovery is truly what I think drives many of us in terms to understand what is it that is happening. And in many ways, it's like an art and a creative process that we're doing. But like art, the fundamental research also has value attached to it. And when I was thinking and preparing what I wanted to talk about for this talk, I was thinking back to the newspaper article that Luc Tremblay has posted outside his office. So I emailed him, because that's my new mode of communication, and said, "Luc, do you still have that article, and can you send me a picture?" And this is one that really stuck out of my mind because as a graduate student, and especially doing work in the area of autism, I was always asked, how does your lab-based work apply? How are you going to apply this work? And I could come up with applications for sure, but there's a part of me that just said, well, it's because I want to know why, and I want to understand how that goes forward. And what I think really struck me about this article, and they termed this kind of inquisitive research as blue skies research, is that the same reason that we all go through our different research and our experimental studies is to find out if what we think is going to happen is going to happen. And what I found along the way is that the most interesting research is when it doesn't turn out the way we thought. Because if we always knew what was going to happen, none of us would need a job. And so in that way, we can explore and find out what might happen. And in this article that was in the Canadian Association University Teachers Press, we're discussing the fact that this Russell Group in the UK looked at the top 10 or grossing research discoveries. And when they looked at the type of research that these came from, 8 out of 10 of those were from basic science, where the original developers had no predetermined plan about how they were going to apply that research. Instead, they just wanted to see what was possible, and then other people can come in and see what then is possible to apply that. And so this article is based on a journal article, and she says that this research, she's referring to blue skies research, or this fundamental, often challenges accepted thinking and introduces new fields of study. And so it frees people up to be truly creative. And the tricky part with this, and the challenge in today's society, is that this research is expensive in the sense that we can't predict what the value is going to be. But I'd like to suggest that it's worth the risk in that we don't know where it's going to go, but that we'll miss out on potentially transformative or new initiatives if we're always constrained to that immediate application. And so, yes, it's going to cost some money and there's some risk involved, but that risk has the potential for transforming or changing the ways in which we do things. And what the data actually showed from that Russell Group study is that the economic value is there as well. And so it's part of our job is to make sure that people understand that the fundamental research does have the possibility, but we don't always need to have the answer when we start. So in that, it's definitely important for us to think about how our work might apply and to figure out where it could go. But on that theme of integration is that some of the most interesting changes and applications I think can happen is when one person has an idea and they don't necessarily know where it's going to go, but now somebody else can come along and take that new idea, so the example of the atomic clock, and think about new ways to advance it. And then somebody else can take that GPS and think, Pokemon Go would be really exciting. And so we have that opportunity to then change. And so again, that working together and crossing disciplines allows us to make these bigger advances. But as Larry Brawley mentioned yesterday, I think the important part of that fundamental research is asking that question of why. And so that when we use theory to inform our interventions, it helps us move beyond the question of if. So on the left, we have our single track. And when we ask the question only if something works, then if it doesn't work, we don't have an alternate path. And I think the strength of our work and using our theory is when we ask why, then that helps us understand when it doesn't work in the first direction, it gives us other opportunities or other pathways that we can take. And the example I'll take from the autism world is there are many interventions that people are proposing and trying, and one that certainly not everybody agrees with, but there is a large body of evidence to support that applied behavioral analysis is a useful way to help nonverbal children learn to become verbal. And when we say there's a large body of evidence to support that, what we actually mean is that a third of children respond very well to this intervention. A third sort of respond, and another third don't have any benefit at all. And so it goes back to what Mark was mentioning in terms of we need to understand those individual differences. And when we ask the question of why, then it will help our frontline clinicians and instructors be able to say, okay, this is the place I should start because for most people, this is a good option. But understanding why something does or doesn't work means that when it doesn't work, now we have a reasonable opportunity or understanding of what our other options are and where we might go next. So going forward, I wanted to explore some of the new routes that I see our fields within NASPA going forward. And in some cases, I see our subdisciplines coming together, and I have a few examples of how we've been coming together to provide a more comprehensive look at the sort of human experience of moving in our environment. But I also think there are places where we need to spread out and diverge and work with other wider scientific communities to make sure that our work has the widest reach possible. So a really strong example of where our NASPA members are starting to bring together our different subdisciplines for a more comprehensive understanding would be Gabby and Rebecca's recent model and theory around the optimal control of learning movements. And now we're starting to bring in these ideas of motivation and how that then changes our practice, which then changes our learning. So we're already starting to see how these different fields come together. And I think in the next 10 years will be the opportunity for various NASPA members to test these ideas and see when and where they don't hold up. And that's really the importance of having a testable theory that we can then look to see whether or not our predictions are valid. And so certainly two frameworks or theories that have contributed to much of the work at NASPA are schema theory and dynamical systems. And these have informed much of the work that has gone on at NASPA over the preceding decades. And they've continued to develop and be criticized and adapted. And I think that's really attributed to how robust these theories are. But at this point, we still have these two different theories. And I think coming forward, we want to start to integrate and think about when and how they actually do work together. And what makes this so interesting, and why I think we haven't been able to sort of solve this or say one or the other works, or this is exactly how they come together, is that we're using our conscious brains to try to understand these non-conscious behavior. And really, our most skilled movement is done, we'll often say, with automaticity or automatically. For us to move in the most natural way possible, we don't want to think about every little movement that we're doing. When I'm speaking to my introductory motor control learning class, I always say, we don't think in terms of, okay, I need to flex my shoulder, extend my elbow. Can we imagine if we had to plan and think about each individual movement? But at some level that has to happen. But we think in terms of goals and actions when we're interacting with our environment. And so as we go forward, we're sort of tasked with this very complicated task of trying to understand ourselves. So it's really quite the conundrum to try to understand these non-conscious processes. And I think as we go forward, we want to try to pull together our different subdisciplines, and we're already seeing examples of that. In looking at this more broad motor experience that we experience throughout our lifespan. And so I think that topic-based symposiums and research will really help to bring together that integrated research. But this is really where some of those social elements come back. So not just is NASPA a place for us to socially interact, but the social elements really contribute to both how we plan and interact with one another. So we have a growing area of research looking at joint action. So how do we perform cooperative tasks? This relates into observational learning as well. So how do we work with other people to observe and figure out what we're going to do? But of course, those social elements can also change the anxiety. It can change the motivation for some people. So for some people, those social environments are highly motivating. So if they're then engaged in more deliberate practice, then we're going to see more improvements. For other people, those social situations may be more anxious. And so the experience for people is really going to depend on the individual, the task, and the environment coming together from that ecological theoretical perspective. In terms of sensory information, this is where I think our different theories will come together, and I would like to suggest is that common element that will be able to bring these pieces together. So as we heard yesterday and today, we have a nice strong understanding of visual motor control, and that really makes sense. We needed to understand what we see and how we're interacting with one another. But I think in the next decade to come, we're going to start to think about more how those other senses, that overall experience that isn't isolated to just visual information, how that will interact. So auditory information can provide us information about where our movements are going. It can provide and change our ongoing control. It can provide us with feedback. It can also provide us with motivation. And so we have all these different elements that we have to think about how they go together. And so the challenge is having research designs that allow us to answer those questions, but then also think about how they work together. The really challenging one, I think, is going to be somatosensation. So really trying to figure out how that sensation of the body is integrated. And that's because we've got multiple cutaneous receptors, joint receptors, muscle spindles, vestibular apparatus. We have different pathways. And so the somatosensation is truly a task of integration. And for it to work correctly, it needs to be integrated. And it needs to also be integrated with our visual system and our auditory system. And what we see, though, with both schema theory and dynamical systems is that as we improve with the skill, or as we control, the ways in which we can use sensory information improves, so that sensory information helps us to be able to perform that skilled movement. And so I'll provide an example from my own research about how that can change with the individual, the task, and the environment. So motor skills and autism, the sort of larger scientific community at first, motor skills was part of the original description, but the focus was really on the social and the communication skills. But myself and a number of other researchers always argued that communication is based on being able to control very complex movements, in particular verbal communication. And in order to do that, we need to do it without consciously thinking about it. And when we look at these more simplistic lab tasks, that was one of the questions that would often come up for me. What does this have to do with social interaction? And when we're looking at these basic reaching movements, what we see in research in my lab and others is that if we ask people to slide their finger on the table, that individuals with autism and individuals without can both perform that task in the same manner with similar planning, albeit a little bit slower, as well as execution. But if we ask people to reach through the air, like I need to reach out and grab my cup, like I need to put something in the oven, then now we start to see differences in planning and control between the two different groups. And this ties nicely into the very well-established research that individuals with autism experience sensory information in a different way. And so I think this is an example of how the sensory information can be used differently by different people. So that individuals with autism like to use that tactile feedback. It relates nicely if we're thinking about integration with the neuroimaging research showing that their sensory motor cortex is highly connected, whereas the connections with the visual motor cortex, those connections are not as strong. And so when the task is to slide on the table, they can take advantage of that tactile information and adapt their behavior, but they're accomplishing the task using a different pathway. Whereas when they're asked to reach through the air, they can use the visual information, but it's more difficult. And so now we start to see differences. And so I think what we're really seeing is our system is very flexible and we have parallel pathways. And we have to start to try to map out what those parallel pathways are. And we can adapt, of course, to different tasks and environments, so we can make use of different information, but I think that changes. So, for example, with somebody with autism, it's not as easy for them to use the visual information more. Going to Mark's talk, thinking about older adults and their ability to use sensory information, the sensory receptors don't become less sensitive as people age, and so they have to change the ways in which they're using sensory information. And so that common piece is that we get better at using that sensory information. The challenge for us is that we have to do it without consciously thinking about it. So we don't have this nice little picture that says, this is what I'm doing. I think we should start to define and use our different understanding of things like continuous tasks and novices and look at those changes across the lifespan to consider how our control mechanisms change under these different conditions. And I think when we have this more unified look at the motor experience, that will help us be able to communicate to engineers and teachers and therapists about how they can apply this to their own individual situations. So one example where we can use different control mechanisms to accomplish that same goal is Parkinson's disease. So middle-aged and older adults, they have lots of experience walking, and I think when their goal is to get from one place to the other, then yes, they are using many of these control mechanisms that are more subcortical and not as conscious. But going back to the idea of parallel and redundant pathways, we have other alternatives. So when somebody with Parkinson's disease, now they have damage to their basal ganglia, and some of those more automatic pathways are not functioning. Yet, and of course this doesn't work for everybody, and which gets into the interesting part about understanding individual differences. But for some people with Parkinson's disease, you can use almost like a railroad track on the floor, and they can change the task such that instead of saying, I want to get from A to B, now I'm going to engage my gait, they can change the task so that their goal is to step over the line. And so yes, arguably it's a different task, but I think it highlights that we can achieve the same goal of getting from point A to point B, and in both cases using walking, but very different control mechanisms in order to get there. And so by understanding how those change with expertise and across different tasks, and being able to map that and understand how now that changes with different social, situations, when we have to work with other people, and as the sensory feedback that we have available to us, how that changes, that will help to give us a more coherent understanding of that motor experience. Which will, I think, really help us in our ability to work with and apply and help others apply our work, as well as ourselves, in the wider scientific community. So others have mentioned that imaging has really changed and evolved, and I think will open up many new opportunities for us in the next 10 years. The ability for more portable imaging will really help the ability to look at the processes and the control mechanisms in more real-world tasks. Their engineers are getting better and better at mapping the brain. So my husband thought initially this was actually another Cirque du Soleil picture, but in fact that is a sagittal view of the cortex. And this is diffusion spectral imaging, and it's a new technique that really allows us to look at those different pathways. But what's important, I think, for us to remember is that these different imaging techniques will tell us what areas are active or where the brain is active, but it still doesn't tell us about the strategy. And that's where our fundamental understanding and our theories will be critical, because just because we know what areas are active, we still don't have a way of finding out the strategy. And so when we can connect and work together with the imaging, and many of the NASPA scientists are already doing this with TMS and fMRI, when we do that, and when we stay connected and working with some of these newer techniques, we'll be able to help inform how they're developed, and so that they know, well, we need to find out this, then the engineers can start working on that element of it. But it will also help the imaging work to be more relevant, because we'll be able to use the new information that we have to explain why. I'll move down to the idea of rehab. I feel in the next 10 years, we certainly have many examples of physical therapy working, and many physical therapy researchers working with NASPA, and Carola Winstein being an excellent example. I think in the next 10 years, we'll continue to see that connection, and if we have this more unified look at the overall motor experience that takes into account the changes with injury, because of course sensory information is affected by injury, but also those social elements, that more complete understanding of the motor experience that can be brought into the rehab world, so that physical therapists and occupational therapists can then use that information for their more individualized approaches. So it goes back to that idea of group and looking at the group effects, and we need to look at the group effects to figure out a starting place. But they still don't help the frontline clinician with the person that walks through the door, because they're an individual and they have to be able to work with that individual. In terms of education, of course we have our roots with physical education, but I've been surprised in recent years about how disconnected in some cases, certainly not all, but in some cases we are from the physical education world. And so in the next 10 years, I think we do need to do as Mark said and reach out and make sure that we're helping each other develop on our end some of the fundamental work and where we see the application, but so that we're working with them to find out what are the current questions in their field that they need help with, and how do they see they could use our new models, because I think in some cases they're not aware of some of the newer motor behavior research. Design, and in particular here I'm thinking about engineer design, I think is an area that we could certainly do more in. Richard Schmidt, of course, and many others have worked with different design companies, but it always fails to amaze me that when I talk to some engineers and they have no idea about humans, I'm not even sure that they know we have arms and legs. And I think we could do a lot more in terms of reaching out. And this is where that fundamental and basic research, I think, is extremely valuable, because we can have the goal of having systematic reviews and a lot of research to support things, but when it comes down to it, when you're designing something new, it won't be new and innovative if there's 10 years of research to support it. And so in order to design these new interfaces and approaches in a way that is the most effective and the safest, we need to make sure that we're communicating with these other wider scientific disciplines about what we do know, because I think we have learned a lot and we will continue to learn more, but we need to make sure that information is getting out there. So thinking about that, I think we really need to make sure that we're driving our train and moving forward and reaching out with those different communities. So on that note, I think we've done a really great job of having integrated approaches. We already integrate across our different subdisciplines, and it's really exciting to see. But in the next 10 years, I think we need to make sure that we are making our tracks available and visible to the wider scientific community. And I'd like to sort of take a different view on this idea of knowledge translation, in that it's knowledge translation being that we want to communicate our scientific work to the community and make sure that it's being applied. But I also think that we want to make sure that we are engaging in this knowledge translation in terms of translating our basic work, and not that we need to always figure out the application. In some cases we will, but that we need people to be aware of our work so that they can see those new applications that we don't see, because they have a different background and they'll apply it in a different way. So I think this is particularly important with the speed with which design is happening. The technology is changing so quickly. People aren't going to stop to find out what a large body of clinical trials or a large body of experimental work, they're not always going to stop and find out and take the time with the design. So we see the different industries in rehab and sport and training. If there's money to be made, someone is going to go and look at making that money. But if make sure that we're communicating that NASPA is the place, if you want to find out the most current information about how humans interact with their environment, how they learn skilled movement, that then you can have a design that is the most informed going forward. And yes, that testing of that new design should come forward, but as we've seen, people are jumping to new things without waiting for that evidence first. So with that speed and that pressure as well for us as scientists to translate our knowledge, I think that theoretical work is becoming even more important. So just to summarize, I think we've seen lots of adaptations and changes, and some designs will come and go, but the strong design in our analogy of the train has continued to push us forward. Things are moving faster and the technology is changing, and so we want to continue to adapt and change and work with these, for example, new imaging techniques. But we have those strong roots in that strong design in that theoretical work that I don't think we want to lose sight of. So I see us in the next 10 years having many applications to many places, working more closely with education and rehab and design so that the reach of our work is that much greater. But I also see us coming together with a more unified approach in really mapping out how does the control change across from a novice to an expert, how does it change across the lifespan. Children and adults and older adults are going to have different attentional capabilities, different abilities to process the sensory information. So how does that inform our control? And looking at some of these parallel and redundant pathways, we are very flexible, which is one of the things that makes us so adaptable. And so I'd also like to challenge Elon Musk in that I don't think we need to worry about artificial intelligence taking us over in the next decade. But instead, that by thinking about why and how things work, that it will really help us to see these applications across the different fields. So I really think as an organization, we want, again, to be known as the place to go to figure out how humans interact in their environment and why the different limitations occur so that new designs and new therapies and new educational strategies can be as informed as possible. So, as Digby kindly pointed out to me this spring, I have actually been around for a while now. And so as I was making this slide, I did realize that there are many people that have influenced me, and definitely as an organization, either directly or indirectly from reading and observing, I've learned a tremendous amount. But I wanted to take this time to thank those that directly have influenced both my passion and my interest for research, starting from undergrad all the way through to my postgraduate training. I'd like to thank my husband for always keeping things interesting and helping me answer why and challenging the clinical application and the fundamental. It's really an exciting world to think about why things work, but then looking at how you can apply that clinically. I'd like to thank all of my collaborators and students as well. And I'd just like to summarize by saying I think that our NASPA train will be a very popular train. Seats will be hard to get, and I'm really excited to see where that train goes next. So thank you.